Okay, before I do that last example from yesterday, I wanted to do just kind of a reminder, guys, of what we did yesterday. So let's do an example on your additional notes first, before we do the one that says challenge. Okay, so let's say I have 6x plus 24 over 3x squared plus 5x minus 2 times 3x squared minus 7x plus 2 all over negative 5x minus 20. Okay, so I'm just making this up. It's going to kind of help us with our remembering what we did yesterday. It's kind of hard to see. That's a 5x, not 6x. There we go. All right, so if you remember, when we're multiplying these rational expressions, we need to factor as much as possible. So I'm going to factor the 6x plus 24. It's going to factor by pulling the 6 out. So you have 6 times the quantity of x plus 4. Below it, I have 3x squared plus 5x minus 2. So that one factors. I would need 3x and x. I need numbers that multiply to be 2, negative 2, so I need 2 and 1. They need to be opposite signs. And then those outer and inner terms need to combine to be 5x. So think about where you would put the 2 and where you put the 1. Yeah, so the 1 and then the 2, right? So see how it's 6x minus 1x. So that's how you get 5x. All right, on the next one, you have 3x squared minus 7x plus 2. So let's do 3x and x. You need numbers to multiply to be positive 2, so they need to be the same sign. So either 2 and 1 or negative 2 and negative 1. You guys see how they have to be negatives to make negative 7 on the inside? So think about where you'd put the 2 and the 1 so that your outer and inner combine to be negative 7. So you need the 2 here and the 1 here. So we have that. And then the very last thing, I have negative 5x minus 20. So pull out its common factor. So the negative 5, and you'd have x plus 4 left. Okay, now this is like you have one big fraction. I mean, think of multiplying all of the top together and all of the bottom together. So anything on top is going to cancel with anything that's on the bottom. Okay, so if I have 3x minus 1 on top and bottom, it's going to cancel. If I have x plus 4 on top and bottom, it's going to cancel. So in the end, you have 6 times x minus 2 over negative 5 times x plus 2. And you can leave your answer like that. That's no big deal. Some of you guys like to go the extra step, which is fine, and multiply those numbers in. It doesn't matter. I mean, I'll grade either one. Personally, I think it's easier if you just leave it factored, you know, saving you a step. Yeah?
If you have, like, let's say you have 3x on the top and then you have, like, xy on the bottom, can the x's cancel?
Because it's still just, you're thinking of 3 times x,
Like,
x times y. What do you mean different equations?
Like if they're still separated. Like if it's like 3x over like 2 times like 2 over xy. Like,
yeah, then the x's will cancel, yeah.
Oh, okay.
Yeah, because what you're doing is you're just thinking of, you're multiplying across the top, so you'd have 6x over 2xy, and now you can see that they cancel, right?
Okay.
Does that make sense? So you're kind of avoiding multiplying it out. You're reducing as much as possible before you multiply out. Yep.
Since there is like an x minus 2 and an x plus 2, what if you try to do like negative 1 or whatever to cancel them out?
Yeah, those don't cancel. And again, if you get confused on whether things cancel, plug in numbers. So if you have x minus 2 over x plus 2, plug in like 4. If you had 4 minus 2 over 4 plus 2, can you just cancel the 4s? you'd end up with -1, right? But what is 4 minus 2 over 4 plus 2? See how that's 1/3? You can't just cancel those 4's then. Okay, so always think about plugging numbers in. Oh, are you talking about like the one where we had x minus 4 and 4 minus x yesterday? Okay, in order to cancel those and put a -1, like cancel these ones and put a -1 out front, they would have to be opposite signs on every single term. So see how you have x minus 2? You would need to have -x plus 2 on the other one. See how we don't have a -x in front of there? So they're not opposite. Okay, any other questions from yesterday? Alright, so let's try that challenge problem. It's a tricky one. Okay, Brittany drives 50 miles at a rate of 60 miles per hour. On the return trip, she travels at 50 miles per hour. What is her average speed? Okay, so these are always on the SAT. I know I didn't know how to do these in high school, so I probably missed it on my SAT. So it's kind of tricky because when you look at it, you're like, oh, she went 60 miles per hour and then she went 50 miles per hour on the way back. She went the same distance, so her average speed has to be 55. That's not how that works. Okay, so average speed. Sarek's laughing because he's done the same mistake in the past. So, so average speed is going to be. Do you guys remember the formula that relates rate, time, and distance? Distance equals rate times time. So if I'm talking about the speed, it's going to be the total distance divided by the total time. Okay, so for the whole trip, what was the total distance that Brittany traveled? 100 miles, right? 50 there, 50 back, so 100 miles. Now we don't know the total time that it took her. That's what makes this tricky. We know that her rate was 60 miles per hour, and she did that for 50 miles. Okay, the other one's a little bit easier. She traveled, 60, yeah. She traveled 50 miles per hour, and she went 50 miles. That one's easier. If you went 50 miles per hour for 50 miles, how long were you traveling? 1 hour, right? Does that make sense? So we know the second part of the trip took 1 hour. Okay, now is it taking less time on the first trip or more time? Yeah, it's taking less time, right? She's going faster. Okay, so we need to think about this. How do we find that number? Any ideas? How do I find the time that it took her for the first trip? Go back to this equation that we talked about, distance equals rate times time, and maybe use that. We're trying to find the time that it took her. We know the distance she went. We know the rate that she went. So if we had distance equals rate times time, you know that she went 50 miles at a rate of 60 miles per hour. So what's t? If I solve for t? 50 over 60, right? So 5/6. So that's 5/6. So it's less than 1 hour, 5/6 of an hour. Okay, then we solve it out. So I have 100 over 5/6 plus 1. So that's 100 over, we're going to think of it as 5/6 plus 6 over 6. So it's 100 over 11 over 6. Do you guys remember when we had these complex fractions? That's what they're called, fractions within fractions. So how can I rewrite that? Yeah, I'm going to do, instead of having 100 and then divided by 11 over 6, it's the same as 100 times 6 over 11. So whatever 600 divided by 11 is, can you guys find it? That's your answer. 54 what? Point what? It's repeating, okay. Yep, 54.54. Okay, and that's the tricky thing. So when you guys take your SATs, here's the way I want you guys to think about it. I want you to think, okay, the logical answer is that you went 50 miles at a rate of 60 and then at a rate of 50 miles per hour. So you're thinking it's 55. That is not the answer. Cross that one out. Now think to yourself, well, for part of the trip, she was going, really, really fast. She was going 60 miles per hour. She was going more than that. Was that for a longer time? You can kind of think through it and you can think if it's going to be more or less than 55. Okay, but really this is the way you'd have to compute this. You'd have to do total distance divided by total time. Okay, so let's try this one. So Jake averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip when walking uphill. What is his average speed for the entire trip? Round to the nearest tenth. Okay, this is a hard one. What's different about this problem? What are we missing? We're missing the distance. It actually doesn't matter on the distance. You don't need it. So we're going to let D equal the length of the trail. So its average speed is going to be the total distance divided by total time. So its distance is going to be D plus D. So uphill and then downhill. 2D. Now we have the rates. Remember, this is time here, so distance is always rate times time. So if I want time, I'm going to take my distance and I'm going to divide by my rate. So the number that I'm going to put here is D over 1.4 plus D over 0.8. Does that make sense? Okay, so I get 2D all over. I want to get common denominators for this bottom two fractions. So I'm going to multiply the first one by 0.8. So 0.8D over 1.4 times 0.8 plus 1.4D over 1.4 times 0.8. So I multiplied by 1 by 0.8 over 0.8, and the second one by 1.4 over 1.4. So you have 2D divided by 0.8 plus 1.4 is 2.2D divided by, can somebody do 1.4 times 0.8? 1.12. All right, so that means I have 2D, you can use the obelisk, old school division sign, divided by 2.2D divided by 1.12. Are you seeing why this D doesn't matter? Yeah, it cancels out. You have one on top and one on bottom. So it didn't matter what distance you went, because it's the same for both anyway, and it ends up not mattering. All right, so you get 2.24 divided by 2.2. So somebody find that. 1.02. Okay, and it's in miles per hour. This last one was in miles per hour too. All right, makes sense?
Yeah.
They're tricky. Just know on your SATs, it's not the one that you would think, On this one, when I see 1.4 and 0.8, I'd be like, oh, I'm just going to average the two. It's not what that ends up being. Okay. All right, so let's do the next section. This one's a short one. All right, so adding and subtracting rational expressions. Okay, so we multiplied and divided rational expressions last time. So now we're going to add and subtract. So the thing that gets confusing with fractions when you're adding and subtracting is you have to get common denominators. So that's the big thing. We have to get common denominators. Okay, so let's do a little review with normal numbers, so normal fractions. So if I have 1/3 plus 1/4, remember you multiply the first one by 4 over 4, and multiply the second one by 3 over 3, so that they have a common denominator of 12. So you'd have 4/12 plus 3/12. So that way you get 7/12. Okay, but you don't always have to use each denominator. Like I don't have to always, you know, like this next one I don't have to multiply by 32 and 64 on the 16. This one I'm going to make a little bit easier. I'm just going to make the denominator what? 64, because they're all divisors of 64. All right, so I'm going to multiply the first one by 4/4. That's going to make 64. I'm going to multiply the second one by 2/2, and then the last one stays as it is. So I'm going to have 12/64 plus 2/64 plus 5/64. So I get 19/64. Okay, sometimes it will reduce down more, but we know 19 is prime, so. All right, so what we're doing there is we're finding what's called the least common multiple for the denominators. Okay, in other words, we're finding common denominators. Okay, so when it says find the least common multiple in this next example, it's saying if these were denominators, what would your common denominator be? So you might want to write yourself a note. What would common denominator be? Okay, so I have 4x squared y cubed and 6x to the fourth y to the fifth. So I'll put those on denominators so you guys can see what I'm talking about. Okay, let's look at just the numbers. If I had 4 and I had 6, what would my common denominator be? Nope. You guys are thinking the greatest common divisor or greatest common factor. You would need 12, right? If you had 4 and 6 in your denominators, you would need to change those numbers to 12. See what we're doing? Okay, now let's say I have x squared and x to the fourth. What would I need to make my denominators? X to the fourth, as small as possible. So x to the fourth. So basically you'd multiply this first one by another x squared to get it to be the same as the other one. All right, if I had y to the third and y to the fifth, y to the fifth, right? Okay, it has nothing to do with those numbers. Like it's not saying 2 and 4 have the least common multiple of 4. It's saying if I have y cubed and y to the fifth, how many more y's do I need here to make it the same as the biggest one? I would just multiply this one by y squared, right? Yeah. And then it would be y to the fifth. You guys look very confused. What are you confused about? Yeah, you'd multiply. So like this one, this whole fraction, in order to make it 12x to the fourth fifth, I would, x to the fourth, y to the fifth, I'd multiply by 3. Oops. I'm trying to write next to it. 3. That makes the 12. How many more x's do I need? Yep, so I need x squared. How many more y's do I need? Y squared. So I'd multiply this one by 3x squared y squared on the top and the bottom. And then I'd multiply the second one by, I need 2 to make 12. And then x to the fourth, y to the fifth, I already have. So 2/2 is what you'd need. Does that make sense? Okay, let's try this next one. What?
So is nothing over 12 x to the fourth y just the answer?
Yeah, I mean, I don't know what the numerators were. I was just saying, if these were denominators, what would the common denominator be? Yeah.
So when multiplying variables, you just add it, right? Like you just then 3.
Yeah. So if you have like x to the third times x to the fourth, remember you add your exponents. Yeah. Okay. All right, so on this next one, think about what these denominators are. It's x squared minus 2x minus 3. And the other one's x squared minus x minus 6. But think about those factors, what factors they have. Okay, so when I factor it, I have x minus 3 times x plus 1. And the other one I have x minus 3 and x plus 2. So what else does the first one need? It needs what?
The x plus 1 needs to be
On the other one, is that what you're saying? Okay, so when you look at this denominator, so x minus 3 times x plus 1, what is it missing from this other denominator? X plus 2. So it's like you'd multiply this whole fraction by x plus 2 over x plus 2. What would you multiply the second denominator by? So the one I'm circling now. X minus 3 times x plus 2, you'd multiply by what? X plus 1, that's the one it's missing. So your new common denominator would be x minus 3, x plus 1, x plus 2. You'd have to have all three. Notice I don't need the x minus 3 twice because they both already had it once, right? So you don't need to multiply again, it's already there. Okay, so let's try some actual problems. Okay, it says add or subtract, identify any x values for which the expression is undefined, so just like we did yesterday. All right, so in this case we have common denominators, right? We have x plus 4 and x plus 4. So if we have common denominators, combine them into one big fraction. So x minus 3 plus x minus 2 all over x plus 4. Denominator stays the same. So I get 2x minus 5 over x plus 4. And that's it. Okay, part B, they also have common denominators. So combine them into one big fraction. But the difference here is that you have a minus. So when you have a minus, I always put parentheses around the second numerator. So that way I know that I have minus the whole thing, 6x plus 1 over x squared plus 1. So I have 3x minus 4 minus 6x, that's a 4, minus 1 all over x squared plus 1. So I get negative 3x minus 5 all over x squared plus 1. So this is just like fractions. If you had common denominators, you just add your numerators, right? 5/7. That's what we were doing. Okay, now these ones are a little bit harder because now we don't have common denominators. So we need to get common denominators. So this first denominator is x plus 4 times x minus 1. That's how it factors. So what does the denominator on the left have that the denominator on the right doesn't have? X plus 1, or x minus 1, right? Does that make sense? So you're missing x minus 1. So we're going to multiply it on the top and the bottom. Okay, now their denominators are exactly the same. They're x plus 4 times x minus 1. So we can combine them into one big fraction. So I have x minus 3 plus, you have 2x times x minus 1. So we're going to distribute. So I have x minus 3 plus 2x squared minus 2x all over x plus 4 times x minus 1. So your final answer, 2x squared minus x minus 3 all over x plus 4 times x minus 1. Now really, going back to 9.1, you really should factor that numerator now and see if anything cancels with the denominator. So you can do that off to the side if you're not so sure. If you had 2x squared minus x minus 3, see if that factors. You'd have 2x and x. You need negative 3x and positive 2x on the outer and inner. So you see how nothing's going to cancel. So you can write that. You can say 2x minus 3 over x, or times x plus 1 all over x plus 4 times x minus 1. See how nothing's in common on the top and the bottom now. So that's as far as you can go. So you could have left it this way, yeah, if you saw that nothing factored. All right, you guys try the next one. So see if you can do B. All right, so for D, like I said, most of you guys just had one little mistake with the negative. So notice you are subtracting out the second one. Okay, so first you guys knew that you needed x minus 3 over x minus 3 so that you'd have a common denominator of x plus 3 times x minus 3, because you knew that's what x squared minus 9 was. Okay, so that means you should have 2x squared minus 30 minus x plus 5 times x minus 3. So remember, if I have a minus, I usually put parentheses around things. That also helps to show you that you are multiplying these two terms together. These two binomials together, I guess. Okay, so you have 2x squared minus 30 minus, I'm going to go ahead and FOIL. So my first term's x times x is x squared. My outer is negative 3x. My inner is plus 5x. My last is negative 15. All over x plus 3 times x minus 3. Okay. You get 2x squared. Let me make this bigger. 2x squared minus 30. And then distribute your negative. Oh. Over here. So 2x squared minus 30 minus x squared plus 3x minus 5x plus 15. So I just changed the signs on all of them. Can you guys see that? And x plus 3 times x minus 3. Combine your like terms. So when you do that, you have 2x squared minus x squared. So you have x squared. You have 3x minus 5x, so negative 2x. You have negative 30 plus 15, so negative 15. All over x plus 3 times x minus 3. Okay, now you're almost done. Remember I said you do want to check to see if that top factors and if they have any common factors. So when you factor the top, you'd have x minus 5 times x plus 3. Right, see how those numbers multiply to be negative 15, the outer and inner combined to be negative 2x. Over x plus 3 times x minus 3. So the x plus 3's do cancel, so you have x minus 5 over x minus 3, and that's your answer. Okay, I did forget to do the undefined part. So remember, something could be undefined from the original, so not from your simplified form. So like in part A, when I look at the x plus 4, I'm like, oh, it's undefined when x equals negative 4. But it's also undefined from the original, so always go back and look at the original. In this case, there was nothing else that made it undefined. B would be undefined nowhere, right? So defined everywhere, I guess we could say. Do you guys see why that one's defined everywhere? Okay, is there ever a place where x squared plus 1 is going to equal 0? No. So write yourself a little note and say x squared plus 1 doesn't ever equal 0. Except for i's, but we don't talk about i's. Okay, C. So part C, it's undefined when x equals what? Negative 4 and x equals 1, right? So it's what the denominator when it was equal to 0. Where are you getting the 3? From, oh, the top? Is that what you said? Nope, it's only from the denominator. Because we could have 0 on the top. That's allowed. 0 over 5 is 0. But 5 over 0 is undefined. Also, yeah. All right, and then D. Now notice in the end, it just looks like it's undefined when x equals 3. But remember, we talked about this. If I'm actually solving an equation and I got like x equals negative 3 as an answer, when you go back to check in the original, if you plug negative 3 in, you get undefined, right? So you actually have to consider the original equation. So, and x equals negative 3. So it's coming from this whole denominator. Okay, so I'm going to give you guys a little bit to work on your homework.